Just a quick disclaimer, all opinions are my own, and I'm still learning how to use OBS, so sorry about the lip sync with the background overlay. It's apparently using some sort of AI model, and I find that it uses all of my CPU when I'm running it at 4K resolutions. So I need to look at that and work out how to get the TensorFlow with the GPU offload working inside OBS. So that's a work in progress. G'day, this is a quick video about using NixOS and large language models, specifically Ollama, Roo Code, VSCode, OpenWebUI, all on AMD ROCM. The agenda for the video is a quick talk about the motivation, quick overview, some discussion about the GPUs, discussion about some monitoring tools, and then Ollama itself, how to do the VSCode stuff within Nix, and then also the OpenWebUI. So motivation, obviously a lot of people are using large language models, particularly for code. It's pretty impressive stuff. I've been using Cursor a lot and it's great, but it can get really slow at times, and I often wonder what's going on. I don't know if it's something in their cloud or if it's me or whatever it is, but it can get frustrating at times, and so I've been wondering about what I could do locally that might be less frustrating. And in theory, if you had enough resources locally, you've got no network latency, right? So it should be a really nice experience. And then we obviously don't want to leak proprietary code into the cloud and so on, so running local LLMs is interesting. The other thing is that if we can learn more about how the LLMs work, we can probably use them more effectively. There were some great talks recently at DevOps LA where some of the Red Hat team presented about LLMD, which is deploying large language models within Kubernetes frameworks. And I was really intrigued by the fact that there's all these key value stores that are getting loaded and unloaded for each of the prompts that you send it. And so I suspect that's where I need to go next, but within the scope of this talk, I haven't done that yet. But that's something for the future. So this is the overview of what we're building. So NixOS with a GPU running Ollama, and then the clients are VS Code with the Roo Code extension that talks over the loopback to Ollama. Pretty straightforward, but it did take a moment to work it all out. So I'm using the AMD cards. The really nice thing about AMD cards is they are cheap. They are much cheaper than NVIDIA cards because everyone wants NVIDIA. So this MI50, which has got 32 gig of RAM, is about $250 on eBay, and that's attractive. I'm actually using two AMD cards. I've got one that's running my Wayland, and the other one is the one I'm trying to use for Ollama. I really love the AMD cards. You just plug them in, they work. No fiddling around like you have to do with the NVIDIA cards. AMD do a really good job of pushing new code into the mainline and making sure that they're in there, and it really pays off. They're really great cards. Installing it on Nix is super easy. There's a bunch of packages. So this ROCM SMI, for example, is very similar to the NVIDIA SMI that many of you have probably used. There's a custom version of BTOP that's got some patches that let you monitor the ROCM, Ollama for ROCM, and whoever's maintaining the Ollama package within Nix packages is doing an amazing job keeping that really up to date. That's been jumping forward in versions as I've been updating, and it's been bulletproof. Just here's a little bit more info about exactly what's going on. So you can see that LSPCI is showing both cards. and you can see ROCM SMI is showing both cards. There's this more detailed view, ROCM SMI show hardware. And just for reference, I'm running a pretty new kernel. Now, I did have some trouble with when I was running queries to this card, because it doesn't have all of the fans, it was getting hot, right? The query would go and all the GPU, CPUs would get busy, and it would get very hot. It would get up to like 100 degrees before I'd kill it. So what I've done is got a plastic shroud from eBay. Someone 3D prints these things. It fits a 40mm fan, so I've got a nice quiet 50mm fan. And then this Corsair Commander thing. It's, I guess, mostly used by like gamers and stuff, because it can control LEDs and all sorts of things like that. But basically it plugs into an internal USB, and it's got full Linux kernel support, so you can control the fans with that. So I've basically got that hooked to the fan, and then I can control it. Here you can see the D message, and there's this command called liquid control. So using that here, I set the speed to 100%, and you can see it went from, this was nearly 3,000 RPM to 5,000, right? So it jumped up. Pretty easy to use. There's also a nice tool that I found called LACT. So there's a daemon that runs, and then there's a client that's an X style GUI that lets you see what's going on. It seems pretty nice. There's a whole GitHub page about it as well. I think you can do fancy controlling of fan speeds and temperatures and stuff, and maybe you can overclock in there. It might have been designed for like Bitcoin miners or something. I haven't really used it to much detail, so it's just a nice GUI for me at this point. Here's the service running under Nix. That was dead easy to run, no problem there. I've also made a little Nix config that just generates a one-shot systemd service to set that fan speed. So just on boot, it sets its fan speed. Really what I need to do is get a controller that's going to look at the temperature and then adjust the fan. But I haven't got that far. Okay, so Ollama. I think most people have heard of Ollama, but it's a nice way of running the large language models. They've got a really great website. They've got lists of all of the models that they have. You can click on each one, and there's like many models. I don't know what they all are, but there's certainly lots of them. And yeah, so that's pretty cool. It's very easy to install on Nix. It's literally service enable equals true. That would probably get most people most of the way there. In my case, I've pinned some environment variables, so it pins Ollama to use a particular GPU. So you can see here I've done that. I also tweaked the context length, which may not be necessary in most cases, because I think when you load the particular model, it sets the context length anyway. But I saw it there, I said it. The other cool thing about the service is this load models. So you can give it the list of models, and now you're deterministic. Yay, Nix. So that works well. When you do reload the NixOS configuration, though, I found that if you add more here, it doesn't restart this service that it created, and so it doesn't load the modules. But if you do a restart, then it will. So I might give you a demo of that a little later on. So ROCM SMI, a bit more detail here. Just as a note, while I was trying to get Ollama to use the correct GPU, I was running this command here, right? So I was passing in environment variables and serve so that I could see what it was doing and make sure it was using the right CPU. And probably if you could follow a similar process. This is my home manager, just a little snippet out of my home manager config for the VS Code, and you can see I've got a heap of extensions here, and the two that I added for this little project was the continue plugin, which I don't think I need, to be honest, and then the Roo Client plugin. They don't, Nix Packages does not include, or didn't when I last checked, the real Klein, but Roo is a fork of Klein, and it seems to be very configurable. There's a bunch of nice videos online about what it can do. I suspect there'll be a bit of a learning curve there. All right, so let's see it, right? So here I am, I'm pointing at my local host. I'm using the Llama model, and we can ask it a query. So, you know, why is the sky blue? And it's thinking, and it's thinking. There we go, it answered. So, yeah, pretty fast, right? That seems great. I don't know what else to show you there. Okay, in this section, I'm just going to run through a bit more of the specifics about the NixOS config. You can see this is my main Nix configuration file. I've got quite a modularized config, and let's just run through here. So, latest kernel packages, that's great. Tracks pretty close to mainline, maybe several days behind the latest releases, but in general pretty good. I've got the init.rd is including the AMD GPU drivers. So as one of the first things that the kernel does when it boots up, it sets the display drivers, and that has the effect that I get nice video resolution on all of my screens. I've got 3 screens, and they're all displaying the kernel booting up. You can see here I've just started to see if I can get Broadcom Ethernet cards with the ROCm V2, so RDMA support. I'm not there yet, but it's a work in progress. So one of the things that I did need to do for Broadcom actually was enable the PCI utils. This is so it can link shared libraries. So I've been using that, and that works great. The other thing to show you is so this is all like the display drivers for the Wayland. And then here, so this is the LACT service, single line to enable it, right? Here's the fan controller, I showed you that already. I actually did another little service, just another one shot to set the fan speed for the main GPU, for the one for Wayland, because I noticed it was getting a little bit warm, so I bumped that up as well. Here's the Ollama service. I think I ran through that config already. So that's most of what I need to show you. I guess, yeah, here's the ROCm packages and VSCode, right? Here it is. So that's most of the config. Okay, I just want to give a quick demo of how to update the Ollama models. You can see here on the left that I've got my Ollama service.nix, and I've got the models in there. So what I'm going to do is comment out this. So we're going to pull in the CodeLlama 7 billion model, and through the magic of Nix, I'm going to rebuild my entire operating system. Honestly, this does take a moment, but when you consider what it's doing, it's fairly reasonable. I'll try to speed it up in the video. Yeah, I'm not sure why this step takes so long. I should probably look at that. Oh, and I forgot to mention that the existing models are all here, right? So we can see we've got CodeLlama 34, Ollama 13, but we don't have Ollama 7B. Okay, there it goes. So we can check we don't have 7B, right? But if we restart the service and we restart Ollama, let's have a look now. It's going to make a fool of me. Maybe it's still downloading it. Yeah, it's busy downloading. Okay, let's just give it a moment. Oh, okay, I think it might have restarted itself. Okay, let's have a look. Okay, it's loaded, and I think now, yeah, there we go. Ollama 7B, done. Oh, and we can test it, right? So Ollama run. Right, oh, it's still starting up. It does take a moment, I'm not sure why. Right, a hello world in assembly x86. Beautiful and fast, right? Okay, this is just a quick demo of the LACT-D and the LACT service. So you can see LACT-D is running. I don't think it uses much resources. What's it using? 50 meg. And then run LACT, which will pop the window. There's the window. You can select which GPU you're interested in. I'm interested in the MI50 with the 32 gig. So that's cool. And then there's a few tabs here, so you can see I think you could adjust the curve, and so I could probably do that on the my card that does have a fan. The other card doesn't have a fan, so this controller won't work. You can look at some software stuff there. This OC I think stands for overclocking, and this is the bit I like, is that you can go in here and see this time series graph of what's going on. So that's kind of nice to be able to see. So if I set that always on top, we could run a model. So it's loading the model now. Yeah, look at that. See, it just did a spike in the megahertz. Please write a hello world program in Python 2.7. All right, that was pretty easy. Let's do one in 2.3. And you can see the spikes there, right? So you can see these power draw spikes in Rust. C++. Cool. So yeah, kind of cute. Okay, so let's do a quick demo of the VSCode and Roo Code. So what I've got here is a new directory, demo directory, and I've created an empty hello.c file. And I know I'm about to use the GPU a lot, so I put the fan speed up to maximum. So now let's start VSCode. Okay, now you can see all the extensions down the side. Let's go to Roo Code. Let's go to settings. You can see there's some profiles that I think you'd mainly use for switching which model you want to use. And I guess you could configure it to use external APIs as well. So, you could point it at ChatGPT, for example. Now, I've got it set on CodeLlama 13b, which it's already talked to Ollama to get that list. So let's select 13b, and I think there are a lot more settings for Roo Code, but you can see down here, right? There's all these settings. There are some videos online that you can find about those. I haven't played with any of them, and you can see I was previously trying to prompt this. So write a hello world program in C into a new file. Okay, and we can see the power draw is going up, the hertz are going up, the temperature is climbing rapidly as it's doing all sorts of work here. So it wants to read a file. Let's approve that. Yes. It should be able to read that pretty quickly because it's empty. Okay, now it's coming up with a to-do list. Apparently that's one of the main things about Roo is it does a good job at creating a to-do list. Okay, here we go. We're allowing that. Okay, here we go. And it's writing out, hello. Okay, there we go. It tried to return twice and then it fixed itself. So that looks pretty good, right? Pretty cool. Obviously, temperature went up a lot and we used a lot of power, but in general, not bad. So we can save that. All right, so yeah, you get the idea. I think there'll be a lot more learning to do with Roo Code. Maybe I'll post something about that later. Okay, thanks. Yeah, just one final thing. I mentioned that I was trying to get the Broadcom HDMI, Rocky V RDMA cards working. So it's interesting. The cards come up fine in the kernel. They're all detected. Because I'm running such a new kernel, it's got the latest drivers, and so you can see them there. I think as IP interfaces, they're working perfectly happily. And I've got kernel modules loaded, and that all looks fine. I've downloaded the latest version of this thing called NixCLI, and that's where things get a bit unstuck. So see how it's saying card not in operational state, no idea why. And if I try to firmware upgrade them, it does not like that one bit. See, I've got some notes here that I took before. I tried to pass it the latest version of the code, which I downloaded, doesn't work. There's this online option, doesn't work. So yeah, I'm a bit stuck on that. I probably need some help from someone from Broadcom or someone who has done this before. In theory though, when I get that working, I'll be able to put workload across multiple GPUs, so it should really open up some scaling. And obviously the other thing I need to look at is water cooling, right? The fan, even at maximum speed, is just not gonna cut it for handling a lot of prompts. So all right, cool.